Okay, so to understand the structural rigidity of a triangle, we first have to understand what a triangle is. To start off, it is the simplest Euclidean shape you could have. Three sides um, with 180 degrees total. So if you look three, you already know this elementary stuff. But one very important thing about the triangle is that it's the backbone to all other polygons. Okay, so you could split any other polygon into a triangle. For instance, a hexagon you could split up into four triangles, a pentagon, three triangles, and a quadrilateral, two triangles, and so on. We just learned this in class. Anyway, that is what makes a triangle very rigid, and that's what we're going to go into next.
So when comparing a square and a triangle together to determine which is a more rigid shape, it's very apparent to see when you apply force to both of them which one is the most rigid. When applying force to a square, you can see that any force will make it give in any direction. However, when force is applied to 2 points of a triangle, it does not give and the vertices stay in their fixed position.
Okay, so following up from the last video, you know that a triangle is the most rigid shape. And here's how it's used in architecture and engineering. Now, this is what's known as a truss. It's basically a bunch of quadrilaterals, right, split into two triangles by another bar, as you can see here. Now, when they're put together like so, it creates a very stable shape that cannot collapse in on itself. And this is used from anything to bridges, to amusement park rides, to the Eiffel Tower. Really, the Eiffel Tower is just a giant truss that just goes vertically. So that is what a truss is, and that is how it is used in architecture and engineering.
Along with rigidity, as you can see, both of the structures are very strong, but when force is applied, the square and the prism here offers more give than the triangle will. And then on top of this subject, there's also more stability with a triangular structure. When you go to flip over a triangular structure, there's only 3 ways in which it can flip. However, with a square, there are more areas where it can flip, which offers more chances for it to flip over, which can decrease its durability and its stability. As you can see, when great force is applied to both of the objects, you can see that the triangle holds its shape better than the square does, which was completely flattened.